Question number 2. This question is about magnetic fields. A. Describe an experiment to investigate the magnetic field pattern around a permanent bar magnet. You may draw a diagram to help your answer. Here, marks is 3. There are two methods here. One is iron fillings method and another is plotting compass method. Iron fillings method place a bar magnet between two books and place a sheet of paper or thin card over it. Sprinkle some iron fillings on the paper above the magnet. Tap the paper very gently. The iron fillings will move to show the magnetic field pattern. Or we can also use place a bar magnet on a piece of paper, place a large number of small compass, plotting compass on the paper near the magnet. Look carefully at the pattern shown by the magnetic field needles of the compass. This is the mark scheme. Here, look at the mark scheme. A method to show the shape, use compass or use iron fillings or iron powder. Use a plotting compass to show the direction. Move the compass in different position, or sprinkle iron fillings on the card and tap the gently, and the iron fillings will reposition, take new position to show the direction of the magnetic field. Then question B, the diagram show two bar magnets. Calculate the diagram, complete the diagram to show the magnetic field pattern. Here two bar magnets, north south. Here south north. So same pole. We know same pole repel each other. So we can draw the magnetic field pattern. This is the correctly drawn field line pattern for the both bar magnets. Here, remember, in south pole the magnetic field lines enter, so arrow inwards. So two magnetic same pole repel each other. That's why this is the answer, correct answer. Remember here I mentioned at least three field line direction given from the north to south. Otherwise you get less marks, so remember this thing. Then question number 3, this question is about food preservation. The diagram shows how the gamma radiation is used to irradiate fruit stored in a wooden box. The radiation kills the bacteria on the fruit. Here is a gamma source, a wooden box containing fruits. Explain why the gamma radiation is used to instead of alpha radiation to kill the bacteria. Remember, alpha radiation has a high ionizing power, but it has less penetration power. Alpha particle cannot penetrate wooden box. So, what is the answer? Gamma radiation is more penetrating than alpha. Therefore, gamma radiation can pass through the box, but alpha Alpha has shorter range. It is stopped by few centimeter air column. That's why we use gamma radiation. Gamma radiation. Next question. Next question. The wooden box has the wooden box has this level. These fruits have been irradiated. Explain why the fruit is irradiated with gamma radiation is safe to eat. Why it is safe to eat. Though gamma radiation is uh, safe, fruit has no bacteria. All bacteria on the fruits have been killed, so it is safe. Fruit has not been contaminated by radiation. Fruit has not been made radioactive. Radioactive source has not been in contact with fruit. That's why it is safe. Safe. This is the question 3. Total marks was 4. Total marks was 4. Then question number 4. It is related to stopping distance. The car driver sees a hazard on the road ahead. The graph shows the velocity of the car from when the driver sees the hazard. It is a velocity time graph. Velocity initial velocity was 15, and when he or she saw the hazard or any obstacle in front of the car, he decide to apply brake. This is the reaction time. So reaction time less than 1 second. So use the graph to determine the reaction time of the driver. You can use 0.9 second or 0.95 second, but less than 1 second. Then calculate the stopping distance of the car. Stopping distance means the sum of thinking distance and braking distance. So here marks is 4, so you have to show the calculation. So if we can calculate the total stopping distance of the car by calculating the area under the velocity time graph. Area under the velocity time graph, it is a trapezium shape. Uh, trapezium shape here. Total distance equal to area under the velocity time graph by area under the line. So thinking distance and braking distance. If you calculate the area of the trapezium, then you get the stopping distance. Next, calculate the acceleration of the car. Acceleration of the car when the car is braking. Acceleration equals to gradient of the velocity time graph. Gradient while the car is braking. That means A equals to V final velocity U initial velocity V minus U by T. Here final velocity of, is 0, but initial velocity was 15. So 0 minus 15 divided by time here time. Look at the answer. A equals to V minus U by T. So time here. Look at the graph again. Here braking time is 4 minus 0.9. That means 3.1 second. 3.1 second. 3.1 second. Last question. Speed of the car affect the thinking distance and braking distance. Discuss the factors that affect the thinking distance and braking distance of the car. Uh, the The factor affecting the thinking distance, if the driver is intoxicated, that means alcoholic, then the reaction time of the driver will be more, as well as the thinking distance will be more. If the driver is multitasking situation, that means multitasking mode, then the reaction time will be more, as well as thinking distance will be more. And braking distance depends on the condition of the road system, condition of the road, condition of the tire, condition of the brake system. If the brake system of the vehicle is weak, then braking distance will be more. If the condition of the tire, that means condition of the tire, that means grip of the tire is less, then braking distance will be more. This 12th question, it is very important question.